Hi, myself Ananya Singhal, and today we'll study what are idempotent matrices. To know about what are idempotent matrices, first we'll know what are matrices. If we go by the definition as written, a rectangular array of m into n numbers, real or complex, in the form of m horizontal lines called rows and n vertical lines called columns is called a matrix of order m by n, written as m into n matrix. Such an array is enclosed by the sign like square bracket. So simply if we know what is a matrix is an arrangement of element into vertical lines and horizontal lines. The vertical lines are known as columns and horizontal line are known as rows, and the order in which order the matrix will be is determined by m into n, that is the number of rows into number of columns, and the element is represented by aij, where I represents the row and j represents the column. So simply this is called the matrix. If we go further, the main topic, that is what is an idempotent matrix. Simply if we'll go by the definition, an idempotent matrix is defined as a square matrix that remains unchanged when multiplied by itself. Consider, if for example, what is idempotent matrix? If there is a matrix A, and if we multiply that matrix with itself, that A multiplied by A, in idempotent matrix, A multiplied by A gives A, means A square gives A. When this condition satisfies, then the matrix is known as idempotent matrix. So consider a square matrix P of any order, but it should be a square matrix of any order, and matrix P is said to be an idempotent matrix if only P square is equal to P. So then it is called idempotent matrix. Now we'll see some example to understand better. So first we'll see the example of a 2 by 2 matrix. There the question is, the matrix is 3, 2, minus 3 and minus 2. And to prove this matrix as an idempotent matrix, what is the condition? We'll multiply the matrix by itself. So when we'll multiply, we'll see we got P square as 3, 2, minus 3, minus 2, which is equal to P. So hence this is an idempotent matrix, because P square, when we multiply P by P, it gives P. So hence verified this is an idempotent matrix. Now as we see in the first example, we will consider the second example of 3 by 3 matrix to understand clearly. So suppose there is a 3 by 3 matrix, as we know the condition of idempotent matrix, we will multiply this matrix by itself, means the matrix B by B itself. When we will see multiplying, we will get 2 minus 2 minus 4 minus 1 3 4 1 minus 2 minus 3, which we can see that is equal to the original matrix, that is B. So hence it's clear then that it is a idempotent matrix. So simply when we multiply a matrix by itself, when it is equal to the original matrix, then it is called an idempotent matrix. Now we'll study some properties of idempotent matrix. The first property is, as we seen in the definition, that every idempotent matrix is a square matrix. The order of idempotent matrix can't be 2 by 3, 4 by 3, etc. It can be only where rows and columns are equal, that is 2 by 2 matrix, 3 by 3 matrix, then only it will be a idempotent matrix. Otherwise these conditions we can't put, and we can't verify a matrix as an idempotent matrix. The next condition is, all idempotent matrices are singular matrix, means that all idempotent matrices determinant, if we take out the determinant of idempotent matrix, it will always be 0. Okay, except there is an exception, that is, the exception is the identity matrix. If we find out the idempotent matrix of same order, then its determinant will not be 0, that is, it will not be a singular matrix. So from this we comes to the next property, the determinant of an idempotent matrix is either 1 or 0. Now it is clear. The last property is very simple. The non-diagonal element or entries of an idempotent matrix can be non-zero entries. We see in the examples, if we go back and see the examples, the non-diagonal elements were non-zero, so it is possible. We can even take out the idempotent matrix by a formula. Now we'll derive the formula. So there is no need every time to put the matrix, multiply the matrix with itself and they take out the idempotent matrix. We'll derive a formula for it. Suppose there is a 2 by 2 matrix A, B, C, D. We'll multiply by itself A, B, C, D, and we'll obviously in the condition it will be equal to A, B, C, D. Now by equating these matrices, we'll get, as we can see here, A square plus BC is equals to A, BC equals to A minus A square. Now we'll equate AB, next element, AB plus BD equals to B. By solving it, we'll get B equals to 0 or A plus D minus 1 equals to 0. B can't be equals to 0, so D will be equals to 1 minus A. So there is a formula. If there is a matrix of 2 by, which is order 2 by 2, we can find its idempotent matrix by putting these two equations, which is BC equals to A minus A square and D equals to 1 minus A. So B will be the A12 and B will be A12, A will be A11, okay, and D will be A22 and C will be A21, and we'll put the numbers. Suppose there is a matrix 1, 2, 3, 4. So if we put the formula, what will be B into C? 2 into 3, which is 6. We'll equate, if this will be equal to 1 minus 1 square, then it will be an idempotent, but both the formula should satisfy. Then only both that D equals to 1 minus A and BC equals to A minus A square, both should satisfy, then it will be an idempotent matrix. Next are the applications of idempotent matrices. What are use of idempotent matrices in our real life? So number first is projection and mapping. Idempotent matrices are often used to represent projections or mapping in linear algebra. For instance, in computer graphics, idempotent matrices can be used to project 3D objects onto a 2D screen. Simply, in computer graphics, to put a 3D image onto a 2D screen, we use idempotent matrices. The next application is error correction codes. In coding theory, idempotent matrices are used in the construction of error correction codes. For example, if understand this application by example, we all know what is telecommunication. Communication that is done for far distances or long distances, that is called telecommunication. And to correct any error we use the data. To correct the data, we use this idempotent matrices. Next is in economics, to determine the input-output analysis. We all know, if we take two industries and we have to compare their input and output, we'll take out and we use matrices, and the matrices we use there is known as idempotent matrices, which we studied. So idempotent matrices are very important in our real life also, as we have seen. It is important in various fields also other than these. So hope you understand idempotent matrices very well. Thank you so much.